Hello and welcome to another tutorial. We are going to continue our discussion on classes and objects, which is the very fundamental topic of object-oriented programming in Java. And we saw the details about creating classes, defining methods, especially method overloading, the concept that was very important. And the gist of it was that the method overloading means you have methods with the same basically with the same name but different signature, which means they have the same name but different parameter types, or the order of parameters are different, or the number of parameters are different. Somehow the signatures are different because you cannot have two methods with the same signature. Every method that belongs to every class in Java has to have a unique signature, right? And then we saw that method overloading happens when you have methods in the same scope, and that's the very key important thing, right? They have to be in the same scope. And we said that every class or every type in Java defines its own scope. Every method defines its own scope, right? So in the same scope, basically, if they belong to the same class, if they have the same name, different signature, that the concept of method overloading applies to them. Now let's look at the constructors, which is the other important topic about classes. And we said that constructors are just special methods. So let's hop in and start looking at this. Providing constructors for classes. Defining a constructor. A class contains constructors that are invoked to create objects from the class blueprint. And again, this goes back to the concept that a class is a blueprint for creating instances or objects of that type. Remember, class is like a type, and type is a more general terminology that applies not only to classes but also to interfaces, enums, etc. Everything in Java has to have a type. Whenever you have a variable, it has to have a type. And in Java, the type is divided in two separate categories. One is primitives, which is very nice that Java supports primitives by default, and the primitives obviously map to the machine, the hardware primitives, with a little bit of exception, because we saw that even on primitives you can say, for example, int.class. So JVM keeps track of meta information of every type when you run your Java application, even primitive types, right? So even primitive types have a little bit of information or meta information associated with them in the meta space of the Java heap. And this is one of the topics that we will look at later in the future lectures. And a type, which class also is a type, is a blueprint for creating instances of that type. And we saw that other types, such as interfaces, those are purely abstract types. If you recall, we said that you don't need to explicitly write the abstract when you define interfaces. If I go back here to my classes, let's see, if we had an interface definition here, for example, feline, we said that you don't have to explicitly write abstract here, but every interface is an abstract construct. The meaning is abstract. Now, this was true up to Java 7, and from Java 8 they decided to add more capabilities or more flexibility to interfaces. So now at this point, interfaces can have, for example, functionalities that are not purely abstract. But again, the core functionality of interface still remains as an abstract construct. That's why the whole declaration of the interface type is still assumed to be an abstract. And whenever a type is abstract, you cannot directly instantiate it. You cannot directly call the new operator on that type to create an object, right? So abstract types you cannot directly create objects of that type. And the whole point of interfaces was to other classes implement multiple interfaces, and each interface adds more capability to your class, right? And then interfaces are also called a super type of your class. So a class can have only one super class, but multiple interfaces which are counted as super types, right? Again, the terminology super type is a more general terminology than super class, all right? So constructor declarations look like method declaration, and that's because by default or at its core, a constructor is just a special method. So all the rules apply to methods also apply to constructor. For example, each constructor has a unique signature, which is again the name and the parameter types, right? and then you cannot have two constructors with the exact same signature. But then constructors can also have access modifiers. There are two exceptions or two main differences between a constructor declaration and a method. A method can be abstract or native or static. A constructor cannot be any of them. You can never have a constructor that is static, because again, a static means it's not associated with a particular instance of the class, which it's not associated with a particular object of that type. But the whole point of constructor is to create an instance of that class, an object. So a static doesn't have any meaning for a constructor. So you cannot say public static and then the name of the constructor. It doesn't work. A constructor cannot be native. You cannot have a native constructor, because native means the JVM has to defer the implementation to a C++ code, which is not the way the JVM has been created or implemented. And then a constructor cannot be abstract, because there is no point. If a constructor is abstract, it means the type itself is abstract. And whenever the type is abstract, I mean, there is no point of providing constructor, because you're not allowed to create an object of that type. So constructors cannot be abstract, cannot be native, or they cannot be static, right? But they can be, for example, private. You can have a private constructor. Any access modifier like public, protected, private, or package level access, they can apply to constructors as well. And we saw a very, very important concept, that access modifiers for a constructor is completely separate from access modifiers for the type itself. For example, when we define this bicycle class, we declare the type as public, right? So other classes in other packages can access this type. And this was useful when other classes want to define a method that takes a parameter of this type. And the prerequisite for that is the other classes must be able to access this type, which means this type is open to other types, which means it's public. But then we said that the constructor itself can be public or private or protected. This means even though other classes might be able to access this type, sometimes we don't want other classes to actually be able to create instances of this type, right? Again, this is two separate things. Being able to access the type itself so that other classes can declare methods that take parameters of this type, or being able to access the constructor. So if the constructor is private but the type itself is public, so other classes can access this type, this class, but then they cannot create an object of this type. So these are two separate things. Sometimes you want both of them to be public. Sometimes one of them is public, the other one, for example, is private. Sometimes a class, you cannot declare a class or type as private. It can either be public or package level, right? Because there is no point of having a private class in a source file if no one else is able to access. That's because that goes in opposite or of the meaning of the packages. You group different classes in the same package so that each one of them can access others' internals, right, directly. So that's the whole point of packages. So there is no point of defining a type of as private, because you just put them in because if it's private, no other class even in the same package can access this type, so there is no point of having that. Alright, so except that they use the name of the class and have no return type. So this is the second basically difference between a method, a regular method, and a constructor. Each constructor has the same signature rule, which means the name and the parameters have to uniquely declare the constructor. But then the name of the constructor has to be the name of the type. And obviously only classes have constructor. Later on, other types like enums, they can also have constructors, but we will see that enums can never have a public constructor. They have to always have a private constructor. And we will look at the example when we discuss the topic of enums. So the concept of constructor doesn't really apply only to class types. It can be an enum type, for example. Again, interfaces can't have any constructor, and we can check that. So let's go to this feline and try to declare a constructor. So for constructor, you just declare a special method that doesn't have a return type. The name of the method is the name of the constructor, and maybe you can take some parameters, and it has to have a body. So the constructor cannot have no body. It has to have a body, even an empty body. Now let's look at what error we're getting for this constructor we defined in this interface. And obviously we were expecting this, right? And it says that interfaces cannot have constructors. Why? Because interfaces are purely abstract constructs, and an abstract construct by default means you cannot create an instance of this type because it's abstract, right? So interfaces cannot have constructors. So have this in mind. This is an important topic. Later on, when we look at the abstract classes, the same rule applies. Abstract classes are also abstract types, with the exception that you can actually have a constructor in an abstract class. And again, we will look at why that is later on, right? But right now, the general rule of constructors, the name has to be the name of the type or the name of the class. Later on, we will see that enums can also have constructors, but they have the constructor has to be private. It's always private in an enum type. Again, the name of the constructor, even inside an enum, has to be the name of the type, right? Constructors can accept parameters, and they don't declare any return type. The reason is that unlike a method that you invoke it on a type or an object of a type, the constructors, you invoke it using the new operator. So a specific operator in Java that calls the new operator, and new tells the JVM, hey, allocate memory for this object, maybe initialize it with the parameters, arguments that are passed to the constructor, and then return a pointer or a reference to that memory location that is pointing basically to that object in the memory. So new operator tells the JVM always return a reference or a pointer to that memory location for this object, right? That's why a constructor doesn't declare a return type, because the return type has to be the same type, the name of the class, the type of the class, or enum, for example. Bicycle has one constructor. To create a new bicycle object called myBike, a constructor is called by the new operator. Remember, new is a keyword, but it's actually an operator. And if you're familiar with C++, you know that new has much more capabilities in C++ than in Java. In Java, you cannot really change the behavior of new, how your objects are created. That's hard-coded in the JVM. But in C++, you have full control over the new operator. You can overload it. Your classes can have their own new operator as a static member function. So we will look at, actually, I will show you an example of new operator in C++, how you can overload it, how you can declare a new operator just specific to your particular class. But for now, in Java, the only role that new operator plays is that you, whenever you call new on a constructor on a type, and you pass the arguments that constructor accepts, then the JVM allocates memory in the Java heap, initializes the fields or whatever member variables are, basically initializes the state of this object, this particular object, based on what happens in the constructor, in this particular constructor, and then it returns a type, right? Basically a reference, or reference is just a syntactic sugar for a pointer, right? A reference to that type, to that created object. So with this statement, we are creating an object, allocating memory, initializing the memory with the correct values, right? And then new operator returns a pointer, and that's also valid in C++, right? In C++, you say bicycle star, which means bicycle pointer. In Java, I mean, the pointer, the concept of pointers is sugar coded so that you don't directly deal with them, but eventually you get a reference which is also pointing to the same memory location. The code new bicycle creates a space in memory for the object and initializes its fields, right? So new always initializes the state based on the parameters that you pass in and whatever code that happens in the constructor. And again, just like methods that we could overload them in the same class, we can overload constructors. So same constructor name with different parameter types, or the order of parameters can be different, some unique signature for each constructor. And then when you use the new operator, based on the parameters or the arguments that you pass, JVM knows exactly which overloaded constructor to call. All right. Although bicycle has one constructor, it could have others, including a no argument constructor. And we said that if you don't explicitly provide a constructor definition that takes parameters, JVM always add a public no-R constructor which has no body inside of it, right? Right now, basically, when we provide a constructor that takes no parameter and has some user-defined code inside the body of the constructor, then JVM realizes, okay, it doesn't add a no-R default constructor which doesn't have any body, right? So as soon as you provide a constructor which takes some parameters, JVM doesn't automatically add a default no-R constructor, right? The code bicycle, you write new bicycle which doesn't take any parameters. Again, JVM at runtime knows exactly which constructor to call based on the parameters that you pass to your constructor, right? Invokes the no argument constructor to create a new bicycle object called your bike, right? Both constructors could have been declared in bicycle because they have different argument lists. As with methods, the Java platform differentiates constructors on the basis of the number of arguments in the list and their types. This is called constructor overloading. You cannot write two constructors that have the same number and type of arguments, and this is called the signature, right, for the same class, because the compiler would not be able to tell them apart. So again, the signature of the method or constructor means the name of the constructor or method. In case of the constructor, it has to be the name of the type and the type of parameters, right? How many parameters, what is the type, and what is the order. Doing so causes a compile time error. You do not have to provide any constructors for your class, but you must be careful when doing this. The compiler automatically provides a no argument default constructor, and it's always public for any class without constructors. This default constructor will call the no argument constructor of the superclass. So that's the important thing, and I mentioned this before. The first thing that happens in a constructor is to initializing the state of the superclass, and that means calling one of the constructors of the superclass. So inside this default constructor that gets implicitly added, it has another assumption that the superclass also has a default no-R constructor. So if you don't provide any constructor for your subclass, and your superclass has a constructor that takes parameters, then you get compilation error if you try to invoke this no-R constructor for your subclass. Let's look at this bicycle class. So this bicycle class has a constructor that takes parameters. And when this happens, when I declare this constructor, there is no other constructor in this class definition, which means I don't have a default no-R constructor. So if I hide this, in the outline, I don't have a default no-R constructor, right? But if we look at the bytecode, let's go to the classes and then bicycle, open this up, class file viewer. There will be a no-R public constructor, and it's here. As you can see, there is a public no argument constructor, and it just has a code that says that, hey, load the pointer for this object, invoke the superclass for this object, which is the object class, and we are in object class has a constructor that doesn't take any parameters, right? And then return. This is the whole idea. So you have to have at least a constructor. You always have to have a constructor. So if you don't provide an explicit constructor, the compiler adds this default no-R constructor, and all it does, it initializes the state of the superclass of your class. In this case, it's just the object from Java lang object. Now notice what happens if I uncomment this constructor, and now there is no, I get this constructor that takes parameters, but there is no other constructor, which means I don't get a default no-R constructor. So if I want to have it, I have to manually add it like this. Okay, so now I have a constructor that takes parameters, I have a constructor that doesn't do anything. But again, know that even if the body of this constructor is empty, the compiler still adds this basically super constructor. So this means point to the super class and call one of the constructors that takes no parameters. We have to initialize the state of the superclass, and even if we don't explicitly do this, the compiler will do it for you. Obviously, you can always explicitly do this. The reason is that sometimes you need to call another constructor of the superclass. Sometimes you have a superclass that has multiple constructors, and based on the parameters that are passed to this constructor, we want to call one of those superclass constructors so that the state is correctly initialized, right? But again, adding this line in this case or commenting that won't change anything in the bytecode. It's exactly the same. In this constructor, right, still we get the pointer to the object and then invoke the superclass and return, right? Same here. So if I uncomment this out, nothing really changes in this constructor. We still get the reference to this object, invoke the superclass constructor that doesn't take any parameter and return, right? So this super call to the no arg default constructor is there by default. Same with here, right? Even in the bicycle that takes a parameter, we are still getting the pointer to this object and calling the superclass constructor, which is an object, Java lang object that takes no parameter. That's it. And this will get added automatically as the first line. And it's equivalent to saying that superclass and call the basically no arg constructor. All right. So this was an introduction to the constructors. In the next lecture, we will continue with the concept of constructors, and I'll show you a few examples. I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.